Today we are going to discuss a new topic, arithmetic progression. For studying this topic, let us go through number sequences. Look at these figures. Can you all see the figures? How many matchsticks do we use in each? Now let us look another pictures. How many sticks are used in each? How many sticks do we need to make the next figure in each section? Let us go through the solution of these questions. Let us write in order the number of matchsticks used in each pattern above, in which first pattern of triangles we have 3, 5, 7, 9 and so on. And in the second pattern of squares 4, 7, 10, 13 and continuous. A collection of numbers as in these examples written in order as the first, second, third and so on according to a definite rule is called a number sequences. I think now it is clear that what is a number sequence. So number sequence is a collection of numbers written in order as first, second, third and so on according to a definite rule. Now let us look some more instances of such sequences. Suppose we deposit 1000 rupees in a bank and what we get simple interest at 6% annually. What would be the amount at the beginning of each year? We all know how to calculate simple interest. I am not mentioning the process here. So let us move to the solution part. At the beginning of the first year, it is 1000 rupees. At the beginning of the second year, it becomes 1060 rupees. At the beginning of the third year, it becomes 1120 rupees. And this goes on the right. That is, we get the sequence 1000, 1016, 1120, 1118 and so on. Let us move to another exercise. Now write down the number sequence got in the instance described below. The perimeter of square with each side of length 1 cm, 2 cm, 3 cm and so on. Also the areas of the square. The next one is the sum of interior angles of polygon of sides 3, 4, 5 and so on, and the sum of the exterior angles. Take this as a practice question and do it yourself. Let us move to the next topic, arithmetic progression. We have seen so many sequences now. Let's have a look at them all together. The first one is 3, 5, 7, 9 and so on. The second one is 4, 7, 10, 13 and so on. And the final one is 3, 9, 21, 45 and so on. The sequence 3, 5, 7, 9 and so on is go from the first matchstick problem. Here we need 3 sticks to make the first triangle, and to make each new triangle we need 2 more sticks. Thus we add 2 to 3 again, add 2 to the sum and so on. To get the numbers in this sequence 3, 5, 7 and 9. What about the second sequence? When we make squares with matchsticks, we need 4 sticks for the first square, and for each new square we need 3 more sticks. Thus we start with 4 and add 3 repeatedly to get the sequence 4, 7, 10, 13 and so on. A sequence which starts with any number and proceeds by addition of one number again and again is called arithmetic sequence or an arithmetic progression. Once more I am repeating the statement. A sequence which starts with any number and proceeds by addition of one number again and again is called an arithmetic sequence or an arithmetic progression. Let us move to some exercise. The multiple of 2 written in order give 2, 4, 6, 8 and so on. Is this an arithmetic sequence? Yes, it's an arithmetic sequence. It starts with 2 and 2 is added to each number. What about the powers of 2, 4, 6, 8, 16 of 2? No, it is not an arithmetic sequence. There is no number is repeated added. Dividing the natural number 2, we get 1 by 2, 1, 3 by 2, 2. Is this an arithmetic sequence? Yes, it is an arithmetic sequence. Now let us look what is common difference. In an arithmetic sequence, if we subtract any number from the number just after it, we get the same number. This number is called common difference. Repeating once more, in an arithmetic sequence, if we subtract any number from the number just after it, we get the same number. This number is called common difference. As an example, look at the 3 sequences we got based on the division by 3. The first one is 6, 9, 12 and so on. The second one is 1, 4, 7, 10 and so on. And the last one is 2, 5, 8, 11 and so on. The common differences of these 3 sequences is 3. Now let us move to an exercise. The first number of a sequence is 10 and the third number is 24. What is the second number? This is the problem we have to solve. Let us move to the solution part. According to the facts given, by adding a number to 10 and then adding to the same number again, we get 24. So double this number is 24 minus 10 equal to 14. This is the second number as the 10 plus 7 is 17. There is another way to do this. We get the same number if we subtract the first number from the second or if we subtract the second from the third. So if we take the second number as x, then we get x minus 10 equal to 24 minus x. From this we get 2x equal to 24 plus 10, then 2x equal to 34. From this x equal to 17. Here is an exercise given to you. In each arithmetic sequence below, some numbers are missing. Their position are marked with a blank. Find those numbers. I think you all understand the concept, so you can do it yourself.